Many species of sharks are considered apex predators in the ecosystem that they live in. And whilst we're starting to get a better understanding of some of the trophic interactions between those predators and their prey, less work has been done on the predatory strategies that these predators use. So, and this is partly due because of some of the logistic difficulties with studying these predators in a natural environment. So what we did in our study, we're looking at the strategies that wild sharks are using to facilitate prey capture, with the overall aim to better understand predatory strategies of sharks. And these projects initially developed from conversation and discussions with colleagues and a wildlife tourism operator who suggested that wild sharks seem to be approaching their prey or the bait in the direction of the sun, so coming from the direction of the sun more so than any other direction. And if this was true, this would suggest that sharks are capable of tracking the sun, which is actually quite an impressive feat. And this has actually never been empirically tested and shown in sharks before. So to test this hypothesis, we went to one of the aggregation of wild sharks in South Australia and spent 30 days looking at these approaches of wild sharks. We recorded over 950 approaches by more than 40 different individual sharks. And to attract the sharks, we're using the standard burley techniques and a bait. And obviously we're aware that this would not exactly replicate the hunting behavior of a shark. It allowed us to collect and record a large number of approaches and investigate our hypothesis and use statistical robust tests on our data. What we actually found is that indeed the sharks were coming from the direction of the sun more so than any other direction and more so than you would expect by chance. Not only that, the sharks also switch their approach direction from an east to west axis. So what I mean by this is that the sharks were coming from the east in the morning, which is the direction of where the sun rises, whilst in the afternoon sharks were then coming from the west, where the direction of the sun when it sets. We also looked at other potential confounding factors or potential drivers of that behavior. For example, with the direction of the tide, direction of the wind, or even the direction of the boat, but didn't find any correlation with any of these other drivers. And as the only correlation that we found was based on the direction of the sun. We also looked at what would happen during overcast days when you don't have as much directionality in sunlight. And as expected, we didn't find any directionality of the approach direction of the sharks during overcast days. So sharks were coming from a much more homogeneous direction during overcast days compared than during sunny days. Finally, we also looked at these approach direction from individual sharks, and interestingly we found that the directionality of approach from the sun was actually different depending on the individual. So in some individuals, these sharks were coming from the direction of the sun more frequently than other direction, compared to other individuals which had much more homogeneous approach directions. And this suggests some obviously differences between individuals, but also some behavioral flexibility. So the developmental history of this approach or this strategy was kind of outside the scope of this study, but what we actually tried to look at is the different hypotheses of how we could explain the functional role of that behavior, or how this behavior would be beneficial to sharks. And we proposed three non-mutually exclusive hypotheses. We proposed that sharks are using this behavior to increase the detectability of the prey or the bait and improve the identification of the prey, for example. And this can be done by avoiding the what we call the disability glare, which can be caused by the sun being in the line of sight of the sharks and creating an overstimulation on the retina. It can also, this approach direction can also be selected by the sharks to try to improve the contrast between the prey and the background, and the visual background of the prey as well. Finally, another possible explanation for this behavior is that sharks might be using the sun glare on the water surface to hide underneath that sun glare. However, obviously this would only be applicable for prey items that are found above the surface, such as, for example, seabirds. So overall, our study found that sharks, or at least some sharks, are capable of tracking the sun direction and using that cue to coordinate an approach direction, which is not a trivial task. And future research will be looking at some of that differences that we found between individuals, but also trying to understand the mechanisms behind that behavior that underpins that behavior.